Let us suppose that we have some data on three variables: semester marks of students, percentage of attendance of those students in semester, and per day study hours at by the students at their home. So three variables were taken in study to know how the marks are varying or why the marks are varying. So the question was that each student is not getting same marks. What is the reason of the variation in marks? Then we found that there may be two reasons. One is attendance of the student, means a student if comes uh, comes for high provides higher student attendance, then he will get more marks, and if there is less attendance, the student will get less mark. So one was the reason at the that attendance of the student. Another was reason was diagnosed as how much time they spent at home. So due to this, again the marks will be varied. So to see how much date my marks is fluctuating by the effect of these two. Is this to fulfill this purpose, we make a regression analysis. So we suppose you are going to the analyze and the regression and the linear. Now I bring my dependent variable semester marks independent and percentage of attendance in independence. So I'm doing a simple regression analysis: y as dependent variable marks, x as independent variable, and I am interested in making a regression equation: marks is equals to beta 0 plus beta 1 attendance. And the value of beta 0 and beta 1 will be obtained by regression method, which I discussed in previously. So just I clicked OK, and I will get output file, and output file is this one. So some basic information will be there. The model summary. The model summary says R. R means correlation coefficient between the variables. R square means model fit, means how much the deviations or heterogeneity of dependent variable is being captured by independent variable. So it shows that about 60% of the heterogeneity or changes in the marks of students are due to their attendance. And the ANOVA table shows that my regression uh, analysis is significant. What is our regression equation? If you want to write regression equation, then you will write marks is equals to constant 30.12 plus 0.57 into attendance. It will be our regression equation. And this regression equation is capturing 60% of the variation in the students' marks. So you can say that the students' marks, but the 60% role in bringing the change in the marks of a student is attendance, or the marks are being changed due to attendance by 60%. Now suppose I am interested in another variable. Uh, suppose I'm interested in another variable, second variable, regression. And in this time, I'm keeping it out, and I brought this per day attendance. Then again, there is a simple regression with the same dependent variable. Dependent variable is marks, Independent is now study hours at home. Again, we will get a regression equation by the help of this beta 0 and beta 1. Now the regression equation is 24.06 plus 8.4 into study hours. Means what this 8.4 is saying? If a student reads 1 hour more, he is going to get 8.4 marks higher. And what this beta 0, beta 1 of the first model says, if a student makes 1% higher attendance, his marks will be 0.57 more. And this model is explaining 60%, and my second model is explaining the variability 68%. Now, if you see the two variables jointly saying that, jointly explaining more than 100% of the variation, which is illogical. So what is happening? Some of the variation are being shared by both of them commonly. Hence, we are getting more than 100% percentage of variation explained. So in place of doing two simple regressions here, it is better to do one simple regression or one multiple regression. And now we are converting, I transferred both variables in independent case. Now what I'm taking one dependent and two independent variable. Dependent is again marks and independents are study hours and percentage of attendance. And then clicked OK. So again, we will get a data file or output file. Now see R square 73 point means the two independent variable are jointly making the variations. Independent variable are responsible for changing the value of dependent variable by 73%. And the model is significant because the F significant value of the ANOVA table is less than 5%, means my multiple regression model is being validated. Now there are two independent variable, attendance and percentage of in class, percentage in the of attendance and study hours at class. The beta coefficient is 5.8 and 0.24. This 5.8 says that if a student reads 1 hour more at home, keeping the effect of attendance on his study neutral, he will get 5%, 5.8 marks more. It is called adjusted effect. Adjusted effect by attendance. In the correlation video, we see that the health funding and the disease were highly positive correlated because a third variable was playing game. So keep the other variables effect neutral, we do this multiple regression. Here, each variable effect is obtained by keeping the effect of other variable neutral. So these are called partial regression coefficients. Actually, they are partial regression coefficients. So if anyone asks which one, and both effects are significant, because here the significant value is 0. So the attendance is also affecting, significantly affecting the marks. The study hours at home is also affecting significantly to the marks, and both are positively affecting because their sign is positive. Now the question arises, which one is affecting more to the marks? Whether the attendance is affecting more or the study hours is affecting more. So naturally, people can say that this attendance is affecting less because it is 0.24, and this study hours is affecting more because it is 5.8 marks increase. But the problem is you can't compare these two values. Why? Because this data is in percentage and this data is in hours. So here this marks is by 1 hour increase, and here this mark is by 1% increase. So you can't compare these two. So if you want to compare out of so many independent variables, which independent variable is affecting more to dependent variable, we see the standardized beta coefficient. Here, the data is converted into standard normal variate so that its unit, it become free. Data become unit free, and now you can compare whose coefficient is more. So since now here the coefficient of study hour is 0.57 and coefficient of attendance is 0.32, then we can say that attendance is affecting less in comparison to study hours. The more heterogeneity in the marks of students are due to study hours. And my model explained 73% of the heterogeneity. Many times people see R square, adjusted R square, because this R square is highly affected by number of independent variables. So if you increase the number of independent variable, your R square will increase. It may happens that the independent variables are not significant, but R square is increasing. So to if adjust the effect of number of independent variables in model, we see adjusted R square. And this is basic idea of this regression analysis. So I'm keeping my video close here. Thank you. Thank you very much.